So we want to talk about binomial distribution. Okay. So the formula that we have for the binomial distribution is P probability of X is N choose X times P to the power of X, Q to the power of X, N minus X. N minus X. Okay. And so when can we use this formula? When can we, claim that I can use binomial distribution? There are 4 criteria that need to be met. So number 1 is that the number of trials must be fixed. So I'm going to say fixed number of trials. Number 2 is that the trials must be independent of each other. So independent trials. Number 3, we will have only 2 outcomes. Only 2 outcomes. For example, it's going to be tail or head, nothing in between. Number 4, each outcome remains constant. Each outcome remain constant. So, there are some problems that they meet this criteria, and binomial probability helps us to calculate the probability in a very, I would say, neat and concise way. Let's have an example. Suppose that we have a certain population, and in that population, 30% of population of a population. And I'm going to just for the sake of clarity, I'm going to change this a large population, like at least state. So 30% of a large population believe in capital punishment. Okay, so that means that 70% do not believe in capital punishment. So out of this population, let's say that 8, and here I want to say 30% of, I should have said here, adults, just for the sake of discussion, adults. Okay. So 8 adults are randomly selected. All right. So part A, let's find out what is the probability that exactly 3 believe in capital punishment. Okay, so first of all, does this question qualify using, binomial probability? We said that there is fixed number of trials. Yeah, we picked 8, so that is fixed. The trials are independent. So you pick somebody randomly, whether this person believes in capital punishment or doesn't. So it doesn't have anything to do with the next one. It's not like, you're picking a card out of a deck of cards and you're not replacing it. Okay. So the trials are independent. There are only two outcomes. This person believes in capital punishment or doesn't. And finally, the probability of outcome remains the same. And that is why I put here a large population. All right, so let's use our formula, go to the next page. Or here we know that the formula, let me write it in a different color. So we said that this is P of X, in this case, P of 3 equals N choose X, P of X, Q of to the power of N minus X. Let me put that in parentheses. Let's continue in the next page. So I have P of 3. What's the probability of exactly 3 believe in capital punishment? N choose 3 is 8 factorial over 8 minus 3 factorial, 3 factorial. And the probability of success is 30% or 0.3 to the power of X, which is 3. Then Q, which is a complement, if 30% complement of P, if 30% believe in capital punishment, 70% don't believe in capital punishment. So that's 70% or 0.7 to the power of 5. And I already put that in my calculator. According to my calculator, to 4 decimal, I get 0.2541 or 25.41% chance that exactly 3 believe in capital punishment. Let's go to part B. Part B is asking at least 3 believe in capital punishment. So 3, at least 3 means a probability of 3 or more. It's going to be P of 3 plus P of 4 plus P of 5 plus P of 6 plus P of 7 plus P of 8. It's very long and tedious if you want to use, do it that way. So we'll use the complement and we say that P of X to be greater than or equal to 3 is the same as 1, which is 100%, 1 minus P of X to be smaller than 3. So that equals 1 minus P of, none of them believe in capital punishment, plus P of 1 of them believe, and plus P of 2 of them believe in capital punishment. So now this is much shorter using the complement. And I already calculated that, for you, one using the same formula, of course, for every probability. 1 minus 2, 4, well, let's say I have 0.058, and then put a plus 0.198, plus 0.296, and that gives me 1 minus 0.552, roughly equals 0.4481, or 44.81% chance probability that at least 3 believe in capital punishment. Part C of this problem, we want to find out the probability that more than 3 believe in capital punishment. Now the difference between this and the previous problem is this one says more than 3. So 3 is not included. So, the probability of 4, 5, 6, and 8%. So once again, more than 3. So 3 itself is not included. So in this part, I'm going to have P of X to be greater than 3. So that means 1 minus P of X smaller than or equal to 3. So that equals 1 minus P of 0 plus P of 1 plus P of 2 plus P of 3. And so I already calculated this separately using, again, the binomial formula. So I have 1 minus, adding all these probabilities together, gives me 0.806. So I'll have roughly 0.194 or 19.4% chance that more than 3 believe in capital punishment. So let's just go back to, okay, this was that's not the page I want. Okay, so this is the page I want. So remember that probability of exactly 3 was 25.41%. Now, if you go to next page, probability of at least 3, that would mean 3 or 4 or 5 or 6 or 7 or 8. So that happened to be 44.81%. And notice that the next part, let's go to the next part or the last part, probability of more than 3. So P of 4 plus P of 5 plus P of 6 plus P of 7 plus P of 8. But since I already have part of these calculated, we use the complement. We use the complement of the probability, and the final answer is 19.4%. Okay, I hope you find this helpful. Thanks.